everyone, my name is Lauren Reid and we're going to talk about basic algebra. So before we get into equations and all that other stuff, we need to remind ourselves of the basics. So our first lesson is called the basics. So I want to get the worst part done first, fractions. Everyone hates fractions. But really, once you understand the fundamental of fractions, it's not that confusing. So fractions is just part of a whole. We have a numerator and a denominator. We all know that. So we have 1/2, we have 3/4, we have 16/17. All of the fractions can usually be reduced, and when we start getting operations, that's when people start freaking out. Equivalent fractions mean that all fractions are equal. So sometimes we have fractions that are really, really big, and we need to make sure they get smaller and simplified. It's a process called simplification. We have 1/2, we have 2/4, we have 3/6, we have 4/8, we have 5/10, etc. Keep going and going, and they can all be reduced to 1/2. Usually, you're just dividing by 2 and 2 and 2 when dealing with 1/2, but they're all equivalent. They all mean the same thing. If we were to look at an image, and this is 1/2, it would be the same. Those are the same thing. If just a visual example, this being 1/2 and this being 2/4, same process. Same thing with 2/3, 4/6, 6/9, 8/12. All those things can be reduced to 2/3, the simplest fraction we have. All of those are equal. So when we get to fraction operations, this is when people start getting scared. Now, adding and subtracting fractions are really simple whenever they are the same denominator. For example, if we have 1/4 plus 2/4, that's easy. That's simple. We're just looking at our numerators. Our denominators just stay the same. When they have different denominators, this is when people start to mix up their math facts. Now, I love multiplying fractions. All you have to do is go right across. When we divide fractions, that one's fun too. So first we'll talk about addition and subtraction. So again, if they have common denominators, you just go ahead and do the operations in the numerator and just bring the denominator as part of your answer. When they have different denominators, we have to go through a process and make sure that they have common denominators. And that's when people start getting tripped up. So we have a couple of examples here. Number 1, we have 11/12 minus 1/12. So we see we have common denominators. We don't have to change anything with that. We just do 11 minus 1, which is 10. And we bring our denominator with an answer. Now, you don't want to keep your answer this way because this is not simplified. There is a number that can go into both the numerator and both the denominator. So you want to make sure you ask yourself, what are those numbers? What are the numbers that go into 10? What are the numbers that go into 12? You can always list those factors if you're not quite sure, or you can do a cheat sheet and use a calculator, but we're going to go the long route. We're not going to use a calculator today. I know that 10 is even and 12 is even. Any even number will always be divisible by 2. So if you have an even fraction and you don't know quite what number goes into it, start with 2 and work your way down. So 10 divided by 2 is going to be 5. And then 12 divided by 2 is going to be 6. And we can't reduce that fraction anymore, but our final answer is 5/6. So that's quite simple. Now, number 2, we have different denominators. We have 6/12 and we also have 1/4. Now, you could do this a couple different ways. You could choose to simplify our first fraction, 6/12, or you can make 4 into 12 as a common denominator. Well, how do you know to do that? You need to ask yourself, okay, first, which is my biggest denominator? Obviously, 12 is bigger than 4. So you would list the factors of 12 or the multiples of 12. We have 1 and 12. We have 2 and 6. We have 3 and 4. And in this case, 4 matches up. So another thing you have to ask yourself, okay, what number multiplied by 4 gets to 12? In this case, it's 3. So we're going to multiply 3 to both the numerator and the denominator. So this is very important when dealing with fractions. If you do something to the top, you have to do something to the bottom, or it's not going to be equal. You just change the whole value of the fraction if you just do one. So you have to do both, top and bottom, numerator and denominator. So what we get here is we get 6/12, our original fraction, plus 3 over 12. And now we have common denominators, and we can go ahead and do that simple addition. We get 9/12. Now, ask yourself, every time you get a final answer, is this in simplest form? Can this be reduced any more? Because we want everything simplified. So ask yourself, okay, what goes into 9? What goes into 12? What are those factors? We have, for 9, we have 1 times 9, and then we have 3 times 3. We already listed those for 12, so we know we can divide both of these by 3. And our final answer is 3/4. For number 3, we have the same denominators happening. So we can just go ahead and move that if we would like, or you can reduce both these fractions. So let's go and do the route of reducing fractions. Let's separate that. 2 over 4, we know, is 1/2, equivalent fraction. Now 4/12. What is 4 divided by 12, or 12 divided by 4? Simplify by dividing both terms by 4. Because we know that 4 goes into 12 evenly. What we get is we get 1/3, so minus 1/3. Now, do they have the same denominator? No. But you can go redo that process by making them common denominators, and it's simpler because our values are smaller. Now, you can only do that if your fraction can be reduced first. So, sometimes whenever your denominator doesn't go into the other denominator, like we saw with 4 going into 12, you just multiply them by each other. So what we do here is multiply our numerator and denominator of our second fraction by 2, and multiply our first fraction by 3. We get 3 over 6 minus 2 over 6. When we subtract that, we get 1/6 as our answer. So as you practice, you'll get used to it. Now for multiplication, you go from right to left. Now some people want to do cross multiplication, but that's not right. You only do that when you're dealing with proportions and you're trying to find a missing quantity. That's not what we're doing here. We're just multiplying from left to right. And then we're, of course, always reducing. So we have 3/7 times 3/5. So again, we're just going from side to side. 3 times 3 is 9. 7 times 5 is 35. So here, you need to ask yourself, okay, can any number go into 9 and 35? Can we reduce any of those? Well, the factors of 35 is 1 and 35, and then 7 and 5. So none of those numbers go into 9. So this is simplified. Now, dividing fractions. There's this little rhyme that I was taught in the 6th grade, and it stuck with me. Dividing fractions easy as pie, flip the second number and multiply. My 6th grade teacher had us repeat that for about 10 minutes straight, so it really stuck in my brain. But first, before we do that, we have 16 over 20 divided by 2. Well, first off, 2 isn't a fraction, but it is. So there's invisible math rules, and one of these invisible math rules is that every whole number is a fraction. The denominator is just 1. It's never usually included, but you should always assume that it's there. So that's our fraction. So in order to divide our fraction, dividing fractions easy as pie, flip the second number. So instead of 2 over 1, we're going to have 1/2 and multiply. And then once it's multiplication, we just go from left to right. We get 16 divided by, or not divided by, over 40. And is this reduced? No way. So the number that goes in here, you could do 2, you could do 4, you can do 8. If you don't know your math facts that well, know they're both even and just start going by 2. So for example's sake, we'll just go by 2. 16 divided by 2 is 8 over 20. Can we keep reducing? Of course. So 8 over 20 divided by 2, divided by 2. We get 4/10. Can we keep going? Of course. Divide by 2, divide by 2, and we get 2/5 as our final answer. And that's fractions. So I told you the hard stuff's over. Integers. Integers is simply a positive or negative number. So -3, -17, +56, +1,000,000. All those are integers. If they have a positive sign or a negative symbol sign, they are integers. This does not include 0. So think about it. If you have $0, you're not in debt, you don't have money, you just have $0. So it's not really something that has a sign. So zeros are not classified as an integer. Something that I see a lot of my students struggle with is thinking of the values of negative numbers. So the bigger the negative number is, the closer the number is to 0 on a number line. The value is greater. So for example, -5 is bigger than -17. Think about it in terms of money. If you owe $17,000, that's not as much as owing $5,000. You owe way more. You're in negative, you're in way more debt if with the 17,000. Make sense? So, adding integers. Adding integers, you just add the numbers and bring the sign over. If they're the same sign, that's 2 plus 2. That's 4 plus 4. Simple math that y'all know how to do. Same thing when it turns to negative, -3 plus -4. You're doing those simple math and then bring your sign with you. Now when they're different signs, you have to subtract the numbers and keep the sign the bigger number. So when they're different signs, I do see a little bit of a struggle with my previous students, but you just gotta think about, okay, what's bigger? That gets to keep the sign. So we have a couple of examples that we're gonna go through. So first off, we have -3 plus -4. And the reason there's parentheses right there is just so you know that, okay, this is not, these signs are separate. Especially when we're subtracting a negative, you definitely don't wanna see them as one simple subtraction symbol when we're really subtracting a negative. So we just use those parentheses just to separate. -3 plus -4. Ignore the signs at first. Do the math. 3 plus 4. That's 7. Because they both have a negative symbol, we have -7 here. And that's it. Again, you can use a calculator, but that's a shortcut. Also, there is more operator error when you use a calculator, especially with different calculators in your signs. They work differently on each one. And a lot of people will just go through on the calculator and get it wrong because the negative's supposed to go before you input the number or the negative's supposed to go after you input the number. So it's just better to do it in your head or on paper. -1 plus 4. So we said subtract the numbers and keep this sign of the bigger number. In this case, for number 2, our bigger number is 4. Obviously, $4 is way more than owing $1. So I just rewrite it as 4 minus 1, which we get 3. Now again, ask yourself, out of that problem, which integer had the bigger sign? So that's 3. Well, that's 4. And we got 3. Positive 3. Our number 3, we have 2 plus -3. So make it a subtraction sign or problem. 3 minus 2 equals 1. And then which of those values had the negative? 3. And so 3 is bigger than 2. We have -1. We have -2 plus -1, and we have 6 plus -4. I want you guys to try this on your own. So if you are taking notes, which I suggest you do, I want you to write this down and pause and then try it. And then when you have your answer, play it. So if you do -2 plus -1, if you add those together, they have the same sign. You should have gotten, if you tried it, -3. For 6 plus -4, 6 minus 4, we get 2. 6 was the bigger number, had the sign, and we get 2. And that's integers, adding and subtracting at least. So subtracting, always remember to keep, change, change. So whenever we're saying keep, change, change, we're talking about the sign, okay? And honestly, this is a skill that you will use in all of these lessons that we'll do today and tomorrow. -4 minus 3. So keep, change, change focuses on our sign. The -4 for number 1 is going to stay the same. That's what we're keeping. We're keeping a negative and negative. And then we're changing subtraction to addition. And then we're changing this 3 that's positive into a negative. And then it's just a normal problem. And we get -7. Now, whenever we're subtracting a negative, we'd still keep, change, change, but there is a shortcut that I'll show you. We have 3 minus -3, so we'll keep our 3 positive. We'll change subtraction to addition, and we'll change this -3 to a +3, and we get 6. I like to draw on there and just connect my 2 negatives and make it a plus sign, because essentially that's what we just did. So it's a little shortcut. It only works when you are subtracting a negative. So for number 3, we have 5 plus 4 equals 9. Simple. So for 4 and 5, I want you to pause, try it on your own, and then press play when you got it. Okay, we have 1 plus -3. You should have connected. We have -1 plus 3. And you should have gotten 2. And then 2 plus -2 plus 7. You should have gotten +5. So I love drawing little plus signs. I love it. It's so fun. Now multiplying and dividing. So this is a little, not a little trickier. There is a shortcut, but it's the same as doing your normal operations, except you just have to be mindful of the sign. So again, just like adding, we worry about the sign last. We're going to do the same thing. So perform the operation. If the integers have the same sign, the answer will be positive. If the integers have different signs, the answer is going to be negative. I was taught the tic-tac-toe for signs a long time ago, and I've used it ever since. I've taught all my students this. The idea is that you use this anytime you multiply or divide integers. So this only works for multiplying and dividing. This does not work for addition or subtraction, only multiplication or division. So what you do is you start anywhere you like, and you go from left to right, up and down. You can go diagonal. It doesn't matter. It's going to work every single time. It's going to give you your sign every single time. So again, focus on the math itself, the division or multiplication, whatever's happening, and then worry about your sign. But that tic-tac-toe is a little shortcut. So -45 divided by 9. 45 divided by 9 is 5. And we had a negative and a positive. So if I go negative here, this is what I'm looking at. A negative and then a positive equals a negative. So we have, -5 as our answer. We have -9 times -4. So we have a negative times a negative equals a positive. So we're going to have a +36 here. Same thing, a negative and a negative. So a negative and a negative is going to equal a positive. So we have +3. And then when they're both positive, that's easy. You already know it's going to be positive. And then we get 63. So let's get into a little more content, a little more vocabulary. We're talking about expressions. So an expression is a mathematical statement involving only numbers and one or more operation symbols. So then we have algebraic expressions, 2 different things. Expressions are kind of what we just dealt with. 3 plus 3, 4 times 2, etc. An algebraic expression is when we start bringing in the letters. Everyone says, why did we add letters to math? Here it is. We're adding letters to math. is a mathematical statement involving letters, which are your variables, your numbers, which are called your constants, exponents, and one or more operation symbols. So we'll be dealing with algebraic expressions for the majority of algebraic algebra. Before we get into that, sometimes we have to simplify them. And we have order of operations. So order of operations is the order we should do operations in. And this usually happens whenever we have our mathematical statements or our expressions, and there's a bunch of different expressions happening. So far, we've dealt with one expression at a time, or one operation at a time, excuse me. And now we're dealing with several operations. And there's an order to everything. So we call this PEMDAS. P stands for parentheses. This is any grouping symbols as well. So parentheses, curly brackets, straight brackets, anything like that is grouping symbols. And we have to deal with what's in our grouping symbols or parentheses first. E stands for exponents. So exponents, usually we're just squaring something or cubing something, multiplying it by itself twice or 3 times. And then we deal with multiplication and division and addition and subtraction. So when we go for multiplication and division, it's important to know that we're going from left to right, just like we would read a book, left to right when we multiply. And finally, when we get to addition and subtraction, we're doing left to right as well. But that should be your very last step. So in order to remember PEMDAS, we did please excuse my dear Aunt Sally in school. And so I teach my students, please excuse my dear Aunt Sally. And they remember parentheses, exponents, all the things. So number 1, we have 2 times 5 plus, in parentheses, 14 minus 2 divided by 2 squared minus 1. So we see a lot of different operations here. And what I like to do is I like to write PEMDAS. Oh my goodness. In my marker. PEMDAS. And then I'll kind of cross it off as I go through it, just to help visually keep me on track. So first we have parentheses. We have 2 times 5 plus 14 minus 2 divided by 2 squared minus 1. What's in our parentheses is 14 minus 2. So we have 12 when we do that. And everything else kind of gets brought down. So 2 times 5 plus 12 divided by 2 squared minus 1. So parentheses, done. Now we go to exponents. So we have 2 squared. When we do 2 squared, that is the same as multiplying something by itself. So 2 times 2, which is 4. So we're going to write 4 in here now. 2 times 5 plus 12 divided by 4 minus 1. So now this is where we start multiplying and dividing, and you have to be careful of the order. You have to go from left to right. So our first multiplication division that we see is 2 times 5. I'll do this first. But the first one we have 2 times 5, which is just 10, plus 12 divided by 4, minus 1. Now we're going to do our division, and we get 10 plus 3 minus 1. 10 plus 3, we can go left to right. We get 13 minus 1 equals 12. And that's our answer. So as you can see, it got wider and started wide and then got narrower as we continue to solve the problem. So for number 2, I want you to try it, but notice how there has to be an order in the parentheses. So if you're doing this on your own paper, which I suggest you do, pause it and try it. And we'll go over it, I promise. Okay. So I assume that you tried it. Make sure you write down your PEMDAS. In this case, we don't have any exponents to deal with, but we do have parentheses. So first, parentheses, we're going to go in order of operations inside the parentheses. We have multiplication. So 2 times 3, we're going to deal with that first. So 10 divided by 2 times 3, which is 6, plus 4, and our parentheses. We're still not done with our parentheses. We have to do 6 plus 4. So you have 10 divided by 10, because 6 plus 4 is 10. And we're just going to get 1, because division was our last operation. Okay? So that's order of operations. You'll see this as we go through solving equations as well. Now, distributive property never dies. Okay, we do it in equations, polynomials, you'll have it in geometry, all the other math that you'll do, you'll have distributive property. So distributive property is a property of equality. Equality meaning equal. That root word equal is inequality. So we use it to rewrite expressions or equations in equivalent, equal forms, okay? So we multiply every time we distribute. So usually there's a term on the outside, and we're multiplying by both the terms inside the parentheses. Now, more likely than not, you'll have algebraic expressions when doing this, not usual normal expressions, usually with 2 letters. But what I do whenever I'm dealing with distributive property is I always draw arrows as a visual to keep track every single time. Because while you may think it's silly to do it whenever we have A and then B plus C, we just have 2 terms in the parentheses, but there'll be times with polynomials where you will have 4 terms, 5 terms, and you'll have to distribute the term on the outside to every single term on the inside. And it's just a visual reminder to help you keep on track. So here we have some algebraic expressions. Here's some letters happening, okay? So we have 8 times y plus 4z. So our 8's going to go to our y and also our 4z. Now, y does not have a coefficient, meaning there's not a number right next to our variable. So we multiply them, we just kind of write them together. We have 8y. Okay, now 8 times 4z, 4 is the coefficient, okay? 8 times 4 is 32, so we have plus 32z. And that's our answer. We're not really simplifying or reducing at this point. We're just rewriting them into being equal. The way to simplify this is to have them have no parentheses. We're not trying to change the values. Remember, it's a property of equality. So they're both equal to each other, okay? So as we go forward, same thing. 5 times 5q. 5 times 5 is 25. Our q just comes along. And then 5 times 2 is 10. Again, it keeps on going. Now we have 2 times 4 here for number 3. So we get 8 plus 8c. Now, our standard form in writing our expressions is our variables come first. And when we get into bigger math like polynomials, our standard form will be a little more detailed. But as for right now, you need to make sure that your variables come first because that's just proper. So 8c plus 8. Yes, they're both equal, but this is just the proper format. So number 4, same thing. We have 4 times 1 and 4 times 5q, so we have 4 plus 20q. And rewrite that in standard form, in proper form. And we get 20q plus 4. I'm going to do one with a negative because all these are positive. So let's say 7 times, we'll do negative. We'll do negative 7 times 2x plus 3. So when you're multiplying a negative, when you're distributing a negative, you need to remember your integer rules. So negative 7 times 2x, well 7 times 2 is 14. But remember, we started with a negative. So negative 7 times a positive 2 is going to make it negative 14x, because we bring our variable. And negative 7 times 3 is going to be a negative 21. Again, negative times a positive is a negative. So when you distribute, just keep in mind your integer rules whenever there's different symbols and signs. Next, and we're almost done, is combining like terms. So combining like terms is a process that you'll use when we factor, when we deal with polynomials, when we do equations in the next lesson. But like terms are the terms that have the same variables and the same exponents. So there may be several variables, or there may be just one variable. There may be different kind of exponents, but it has to look the same. I think of this as last names. They all have to have the same last name when we all combine them. Or you can think about it of having different fruits. There's oranges and apples, and you can't group an orange with an apple because that's not apples. So for number 1, we have 10c, 2c, negative 2c, and negative 5c. All of these are like terms. Okay, so you just go your normal operations and keep your variable. So we have 10 minus 2, which is going to be 8c, minus 2c, which is going to be 6c, minus 5c, we just get c. Also, whenever you have an answer and it's just with a variable and it's 1, you don't have to write the 1. That's another one of those invisible math rules. You can write 1c, or you can say 1c, or you can just put c. They equal the same thing. They're the same thing. Number 2, we have some constants and we have some variables. So we have 3 plus 10v plus 7v plus 10. Now, you cannot add apples and oranges and say you have more oranges. You gotta have your total number of apples, total number of oranges. There are two separate things, okay? So we have 3 and we have 10. These are like terms. Why? Because they don't have any variables. They're the only terms that don't have variables. Now our other, we have 10v and we have 7v. These are like terms, okay? They have the same variable. There's no exponents that we see right now that we're dealing with, but they're the same, so this is why we combine them. And we combine them, it doesn't always have to be addition, like our first problem. They could be subtraction. There's the terms that we're dealing with. So 10 plus 7, we get 17v, and then 3 plus 10, we get 13, so plus 13. And we have this in standard form. Everything is proper, and nothing else can be simplified. It's just there, okay? And you're good to go. Number 3, we have a plus 8 minus a plus 9a. And so here, we really only have a as like terms, and then 1 8. So the 8's just gonna go on the end. We don't really need to worry about it. We know it's gonna be there. But we do need to combine all the other terms. So we have a and negative a and 9a. Now if you need to, just to help you go along, you can write 1a minus 1a, if that helps you. Now 1 minus 1 cancels out, okay? So we can cancel out here, or you could just go through the motions. 1 minus 1 is 0, and then plus 9 is 9a. So 9a plus 8, okay? Now I want you to try number 4. We'll do number 5 together, but I want you to pause and try number 4. I'll give you a second. Okay, so 2v is our only term here. And then our other terms are 6 minus 1. Oops, sorry. 6 minus 1, and we get 5, or positive 5. Okay, simple. Now here is where we start dealing with exponents. And as you can see, x squared and 6x are two different things. The exponent makes them different. Even though they share that variable, the exponent makes it different. So we have 12x squared and 4x squared. Now, again, in standard form, we just had one variable to contend with. When we have standard form, you need the highest exponent to go first. So we have 12 minus 4, which is 8x squared. Okay, and then we have 6x minus 3x, which is just going to be positive 3x. And that's our answer. And that is your basic math.